So yeah, it says assignment 25, but I decided instead of making a notes page and then also having that on your mind, like, do I have to finish this? I thought we would just sort of do some of these together, count this as notes, and then predictably there'll probably be like an assignment 26 where I would kind of keep my nose out of it, get out of your business. Is my TV not on? That's going to be a problem, isn't it? Okay, let me get that going. What's that? Yeah, it's not going to work very well if you can't see what I'm writing. Yeah.
It's just like a
Thank you.
no.
No, no, I usually when someone points and I did it again. I have to turn the TV off when I'm doing certain things. So, right. So let's get to it. We're going to have the same set of directions. If you're working on something else, you got to stop now so that we don't get behind on this. You know me, I'll give you plenty of time to work on stuff. So, um, I don't have these picked out in any particular order, but let's start uh, with problem one because it's the first one. So, like, why not? Everybody get a copy of this? Okay. All right. So let's start with problem one. The order that we do this in, honestly, is I don't really care. I like to start with horizontal asymptotes. I like to do that before I start to dismantle the function. So, is there a horizontal asymptote? Mhm.
Yeah.
It is not at 1/2, and it is not at -1/2. It is at y=0. So remember, if the degree on the top is smaller than the degree on the bottom, then this graph has to tend towards 0 over time. So we can say, and we should all say and agree that there is a horizontal asymptote at y=0. And if you're writing 0, I don't think any of you are, but make sure you don't write horizontal asymptote at 0. Like we can say that when we're speaking casually, but make sure you're always writing the actual equation of the line. Good. It's also good to talk about the vertical asymptotes. And before we can go down that road, we of course need to dismantle the bottom completely, factor that thing down. So to factor down this particular bottom, we want to pull out a -2. And that leaves us with x squared minus regular x minus 6. And what does that become?
So, cool. Oh wait, no. And it's 2 and 3. Plus, plus 3 minus 2.
X minus 3 and x plus 2. If you want them in the other order, like +2 first and -3, you know that doesn't matter. What matters, of course, is that the minus is with the 3 and the plus is with the 2. So the function now, I can do something you can't do with this crazy white pen. I love having a white pen because it acts like because I can't erase a PDF, but I can draw over it in white, which is actually really fun. Uh-oh, I just did that. You didn't see me do that. So I'm going to take this stuff. Okay, this is really going well. I'm glad I'm spending your time for you like this. That was such a waste of my time. And you know what? Things like this in the past, I would take out of a recording, but I'm just going to leave it because this is great. This is why. All right, so I'm just going to go like this. -2 x -3. What an idiot. I know I got my pen thick with 2 C's. Um, God, that was a mess. What a great way to start the hour. Way to go, dude. So do we have vertical asymptotes?
Yeah. Yep.
How many?
3.
Are you sure they're both vertical asymptotes? You should be. Good. Because neither one of these things on the bottom with X's in them has a chance to cancel with anything on the top. So we're sure that there's a vertical asymptote at x=3, and we're sure that there's one at x=-2. And because there's no X's on top, there cannot be any holes. So we are done with the structural sort of introductory phase of the problem. I like personally when I get done with those 3 things, holes and both kinds of asymptotes, I like to structure my graph. So since I'm the one with the fake pen, I'm going to do that right now. So I'm going to make my horizontal go across at 0. And I'm going to make my verticals come down at 3 and at -2. And you're familiar now with this situation. Originally, we had never seen this. Like we only had the 4-quadrant rational functions, but now we have the 6 sections. So we get how this works. Before you and I start worrying about the graph and where are the arms and what does it look like, this is where some newness happens today. So this is why I'm recording this. This is why I'm taking your time, because I want to talk to you first off about something called the y-intercept. And the y-intercept is just something you've been working with since like 8th or ninth grade, right? Since like pre-algebra kind of thing. The y-intercept is the place where the graph crosses the y-axis. How could I find it? Without having a graph. Like if I had a graph, duh, I just look at it. But how do you find it if you don't have a graph? Mm-mm. It's impossible. This is not a straight line. Here, I'm gonna put some points, and I know this is kind of weird, but I'm just going to tell you that every one of those dots is a y-intercept. Okay, I mean not on this graph, but I need you to tell me. I mean, there's always the smart aleck answer. Well, they're all purple. What do they all have in common? Be more specific. They all have an x of 0. And therein lies the true definition of what a y-intercept is. The y-intercept can always be found. So much of math is about you taking charge of a situation. You want something to happen, you make it happen. So what I say is if I want a y-intercept, then I need to go into my function and change every one of these x's into 0. By definition, if x is 0, you are finding the point where the graph crosses the y-axis. I want to get you on, make sure you're on board with that. Anyone want to refute that or rebut that? So we're going to go into our function and we're going to put zeros in place of the x's and grind it out. 0 minus 3 is -3. So I have -2 times -3, and 0 plus 2 is 2. And that's going to be 6 times 2 is 12. So this graph will have a y-intercept way up at 12. I actually can't graph this y-intercept, and that's okay. So I'm just going to write, what's up?
Yeah.
1/12. Thank you. Yeah. So the y-intercept is, oh, what did I just do? Hey, who did that? Where? Yeah, it's back. Oh, woo. The y-intercept is at the point 0, 1/12. Thanks, Bretta. I should maybe, and just think I got to do conferences after this. Maybe I need to go take a little break. Maybe a little nap. So there's one new guy for the day. To find a y-intercept, I make all my zeros into x's. Now, the next thing I want you to find for me is what are called the x-intercepts. And this time I'm going to put an apostrophe because there's often going to be more than one of these. Okay, you're never going to have a y-intercept more than once because then it wouldn't be a function. If a graph crosses the y-axis and then crosses it again, it's no longer by definition a function. So you'll only ever have one of those, but you could have multiple crossings on x. Now that Brenna helped us over that last hurdle, how do you think we find the x-intercepts? Right. There will be none in this particular case. And I'll tell you what, that just because there's an asymptote isn't the reason. Excellent thinking. You can have an asymptote and cross it. I talked to you about this the other day. You can cross a horizontal asymptote. To find an x-intercept, you want to do this. You want to make the top equal 0. And maybe this wasn't the best example to do first because the top of our function is the only green thing on the board, 1. And what can you do to 1? What can you put in place of x to make 1 equal 0? You can't. There's no variable for you to control, right? So this particular function has no x-intercepts. So for x-intercepts, we'll say none. At this point, I think we should, I'm trying to coach you the best I can. I think we should sketch the graph next. And then our final statement is going to be what's the domain. I like doing the domain after I get my eyes on the graph. I could do it right now if I really wanted to, but I think it's going to help you to let's make a sketch. So we have three regions that we're concerned about. We're concerned about the region to the left of the first asymptote, in the middle between the two, and to the right of the right asymptote. So let's get to it. So let's pick a number for x like, oh, how about -3? So if you take, and by the way, I do have your calculators. I didn't charge them, but did you guys bring your forms back today?
Did my
Let me, no, your dad did not show up. I never saw Stone Cold. Do you guys just bring them back on Monday? Does that work? Will you do that? Will you remember? Can you guys, oh yeah, you ready? Oh yeah, boy. Thanks, buddy. Oh, we got three of them.
we were leaving my neighborhood and my dad calls me on the phone and he says, "Is there anything that teachers are concerned about you with?" And
So he's not coming.
oh wait, and he said,
That's fine. So I'm going to send this back with you and you can get it signed. Irene, are your parents coming tonight? Okay. So anyways, we're going to do -3. And if you put -3 in here, boys, stop it up. You're going to get -3 minus 3 is -6. -2 times -6 is 12. Times -1 is -12. I believe it's -1/12. I'm obviously not capable of doing basic things today, but I think it's going to be right about here. And the fact of the matter is that's already almost enough. I feel like we know, by the way, the graph isn't, the graph will eventually tend to the limit. The limit is represented by the horizontal asymptote. So you would be within your rights at this point to just, it's not presumptuous of you to just assume that the graph is going to do this. It's not my finest sketch, but usually they're not. So there you go, something like that.
"So right,
You okay on that?
yep."
Now, what we're going to do is we're going to pick some points. We're going to definitely need more than one. I tried to show you the other day. There are many, many things that the middle can do. The middle can behave like as a zigzag like that. It can behave like a reverse zigzag like that. It can behave like a weird, like misshapen parabola thing like that. Or it can even perform and do weird things like this. There's all sorts of things in the middle. And this can be annoying, but let's work together and let's make a set of points so that we can play connect the dots. I think if we're smart, we should do -1, 0, 1, and 2. I feel like if I nail those ones down, I can get a pretty good picture of what the graph's going to do in the middle. So yeah, we already know 0, don't we? So we can just fill that one in. That's 1/12. And let's go ahead and do -1. I got 1/8. I don't know about you guys.
14, yeah, 414. I got one too.
In case anyone's like wondering what's going on, I'm just taking the numbers, the X numbers, and I'm putting them right into these parentheses, right? Because those are the only X's, so they're all I've got to worry about. So like 1, I got another 1/12.
Yeah.
And for 2, did you say -1/8?
Yeah.
Yeah, that's what I got. So I think this is going to be probably the picture that we need. Hopefully we'll get enough information out of this. We may have to, and again, the calculators will help us immensely on this. We may have to get a little closer look, but let's graph what we have. And I'm gonna go to -1. So I'm gonna go left 1 and I'm gonna go up just 1/8. So just barely above the x-axis like this. At 0, I'm down even closer to the x-axis. At 1, I'm at 1/12. So I'm still down there like this. And then at 2, I'm at -1/8. So like this.
Cool.
Which I gotta be honest is really freaking me out because there shouldn't be.
What?
Oh, it's 1. Where did I get a negative from? Did you give me that?
Yeah, Anderson gave that to you.
Thank you.
Yeah.
Yeah. And that's a good thing. I mean, I'm not happy that it happened, but I'm kind of happy in the sense that when you start to understand and you put all the pieces together, we knew there wasn't going to be an x-intercept, right?
Yeah.
We knew that because we could never make the top equal zero. So then if the graph tells you something different, then you have those thoughts where you kind of go, why did that happen? And then we find our mistakes. So can you kind of see the shape of this?
Yep.
It's going to be a kind of a modified asymmetric parabola looking thing like, ooh. And it never does get down. It never does touch the x-axis. It approaches it, and it's real squishy down in there like that. Okay. And now we have to worry about the right-hand side. And I would be willing to bet that we're going to face the same thing on the right-hand side that we did on the left, and that we really probably aren't going to need a ton of points. This graph feels really, what's the word, like exaggerated, sort of squishy, compressed. So I don't think we're going to see anything exciting over here. What's the first number to the right of the right asymptote? 4 is perfect. So let's plug in 4. What'd you get?
Negative 12.
So negative 1/12.
Yeah.
Yeah, don't go all Mr. Ahern mode and forget about the 1 on top, right? So negative 1/12. And that kind of tells me what I need to know. It tells me that if I'm at 4 and I'm just barely below, just saying that it's below to me is going to be enough. I can then infer from that that my graph is going to behave on this side, just like it did on the other side. Still good?
Mhm.
All right. It's taking longer than I want it to, but it's okay. Teaching math takes a long time. The last thing to complete this, because then we're ready to start thinking about heading towards a quiz now, because you know all your intercepts. The only thing we haven't talked about yet is the domain. So to do the domain, we're going to use what's called interval notation. And you'll remember this, you've seen it before. First off, there are breaks in the domain, so I'm not going to be able to say that the domain goes from negative infinity to positive infinity because there's a break at an asymptote. There's a break at another asymptote. So I'm going to be able to describe this in 3 shots. The first interval is the green interval over here. And you guys, again, that are taking the LCCC class, you have a little bit of an advantage over the rest of us. But does anyone who's maybe not taking that class, just the other folks, remember how to name an interval that goes and describes the green section? The interval goes from the left side, negative infinity, and it stops where?
-2.
At -2. And if you remember this from the old days, the reason I'm putting round around them is that the round indicates that you can't get to that end. You can never get to negative infinity. So infinities always get round brackets, and you don't get to -2, and that's why it's also round. The roundness indicates that you don't get there. Having said that, now that it's a little freshened in your mind, how would I describe the center interval of the domain? I would have to have a union symbol to say that this is going to join with this. Go ahead. So it goes from -2 to 3, and I'm going to union that. This, by the way, this U symbol that you see me doing is just what we do when we have multiple pieces and we want them effectively to form a, well, union. Okay. It doesn't mean they're overlapping. We flip that symbol over and it becomes what's called an intersection, and that will not apply to what we're doing right now. Okay. So the U, the big, tall, exaggerated U, is a union symbol. And what's the third interval of our domain?
3 infinity.
Goes from 3 to infinity.
I feel.
A much lazier way to write this, which I'm totally okay with. I want you to see this before you leave. And there's 100.0% chance that you'll be more attracted to this one, depending on who your teacher is, depending on what class you're in, what the situation is. Some people would say that the domain is all real numbers, not equal to -2 or 3. And 100 out of 100 people surveyed said they like that one better. And it's okay. It's perfectly normal. Some college professors will want you to write your intervals as your union sets. And some teachers will want you to just do it as more of an exclusion. This interval notation more focuses on exclusion. It's saying you can be anything you want to, just don't be that guy or that guy. Whereas the top one is saying you can be all of these, all of these, or all of these. I'll see you Monday. Later. Got it? Okay. Are you okay if we do another one together?
Yes.
It's going to eat up more time, but then we'll just have a work day on Monday. Are we good? All right, let's make sure, let's nail this, drive this home. So the next one is right there. And I'm actually going to copy this onto a different, this graphing on these PDFs makes me nuts because I can't zoom or they get all distorted and stuff. So I'm going to add a page and I'm just going to copy this over on this, and then I'll be right with you here. So first I'm going to pop in a graph. Maybe there he is. And then I'm going to copy down the function. And actually, as I copy it, I think I'm going to have you help me factor it. Could you guys help me out here? I really suck at this factoring stuff. Well, here I can erase. Never mind. So tell me about the top. How do you start the process of factoring the top? You agree with that, Gabe? Definitely want to pull that negative out. And if you pull that negative out, then you're left with x squared minus 6x minus 8 or plus 8. I'm really struggling today. And what does that factor down into?
4 and 2. It's negative x minus
X minus 4 times x minus 2. Nice. And then tell me about the bottom. Yeah, it's the old famous difference of two squares. So x plus 3, x minus 3. So we're going to run our way through the 6-item list. And the order that we're going to do it in, you're going to come up with your own order. I'm not going to be too bossy. I like to do my horizontals first. So I just see you see it, I see it. Is there a horizontal asymptote? Where?
-1.
At y equals -1. Good. And the reason for that is because you can see that the top and the bottom are both the same degree 2, and the ratio of the numbers in front is -1 to 1, which we simplify to -1. So we have a horizontal asymptote. That's massive. That's great news.
Massive.
The next thing I'm going to do is look for vertical asymptotes. And where do I find vertical asymptotes?
The bottom.
In the bottom.
33.
And remember, we shan't jump immediately to the conclusion that things are necessarily vertical asymptotes. We could just say they're bad guys, discontinuities. So we agree, all of us, that to make that be 0, x would have to be -3.
Yes.
And to make this second one equal 0, x would have to equal +3.
Yeah.
I was a little hasty or premature here, but we all saw the writing on the wall. Do either the green or the yellow thing cancel?
No.
So we can go proceed ahead and say they are in fact both vertical asymptotes.
Yes.
Got it? And the fact that nothing canceled anything, nothing with variables canceled anything with variables means there will be no holes. So this is where I like to say, okay, I've got 3 things off my to-do list. I got my verticals, my horizontals, my holes. This is where I like to make a graph, or the skeletal structure of the graph. So I'm going to climb in here. I'm going to hop in and make a horizontal asymptote at y equals -1, like this. And I'm going to make 2 vertical asymptotes, one at -3 and one at +3. The next thing I personally want to do is I want to find the y-intercept. So to find the y-intercept, and remember we got some good info from the back of the room on this earlier. For your notes, make sure you're 100% clear. To find the y-intercept, you change all your x's into 0, right? That's what you do. Be bossy with yourself. Write it down so you don't wonder what to do. So if you change all your x's into 0, it says the negative of 0 minus 4 is -4. 0 minus 2 is -2. On the bottom, 0 plus 3 is 3, and 0 minus 3 is -3. That's just what all the xe parenthesis things look like when we put in zeros. So the top becomes the negative of 8. The bottom becomes the negative of 9, which is 8/9. So when we state a y-intercept, we state it as a point, 0, 8/9.
No,
It was positive.
for both angles.
So I can go to my graph right now and I can go up or go to 0 and I can go up 8/9 of the way to 1. And I can actually say, and this is really valuable information because later when we're trying to build a graph, having that point might make the difference between does the graph look like this or does it look like this? Oops, too far. The next thing we're going to do, and is he with us? The next thing we're going to do, and I regret that our first example, we didn't get to look at this, but there'll be some meat on this bone. We have to find the x-intercepts. The answer this time is not going to be that there aren't any. The answer is going to be actually that there are 2 of them. How do we find x-intercepts?
We have to do the top and do the quadratic formula. Yeah.
No, you do not need a quadratic formula. So again, I want you to write this down. The x-intercept, if you haven't written it down, write it down. To find x-intercepts, make the top equal 0. And the reason for that is because if you can make the top of a fraction equal 0, 0 divided by anything is 0. The function takes on a whole value of 0. And by definition, then you're finding a place where the graph has a height of 0 or sits on the x-axis. That's what we're hunting for. So I ask myself now, it's kind of like finding vertical asymptotes, except I'm not looking at the bottom, I'm looking at the top. What 2 numbers make the top equal 0? 4 and 2. So there is an x-intercept at 4, 0. And there's another one at 2, 0. 5 of our 6 checklist items are done. Holes, verticals, horizontals, y-intercept, x-intercepts. 5 down, 1 to go. And again, I think it's wise to wait on the domain unless you just want to do it. I like to wait. So I'm going to go through now and I'm going to graph my x-intercepts. And so again, I'm going to zoom in a little bit here. I know that there's an x-intercept at 4, 0. So I'm going to zoom in real close here and I'm going to go to 1, 2, 3, 4, 0. And I know that the graph will be touching the x-axis at that point. And where was my other x-intercept? Was it at 2? So there's an x-intercept here. It's like it's playing a game of like Clue or Wordle. Like the more clues I get, the closer I get to constructing the answer, right? All my clues, though, are in one kind of area. They're all over here. So now is the time where we roll up our sleeves and we find some points. So let's start with the region to the left. And to the left of the first asymptote, I see -4. And that may be enough. We can take it a stretch further just in case, -5. And if we need, we can keep going. But let's start with -4 just to get a picture of what in the world am I looking at here. So you're going to take -4 and you're going to put it in place of all of these x's where these purple arrows are pointing. And what it's going to look like, now that I have a little more workspace here, I can kind of show you what I've been doing in my head. It's going to look like this. It's going to be the negative of -8 times -6 all over -1 times -7. So you want to grind out each of those little parentheses sets one by one, and then allow yourself to multiply it all back together. So the top's going to equal 48 with a negative, so negative 48. The bottom's going to equal 7. So we know that's about negative 7. It's really close to negative 7. It's just a hair under negative 7. But that's good enough for me. So when I go to graph it, I'm going to go left 4 and I'm going to go down about 7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and almost 7. So right about there.
6, 7.
What do you suspect is going to happen and when I move across to negative 5? So when I'm going to make a purple X, what I'm talking about. When I move across to the purple X, what are we expecting our Y value to do? It's going to fly upwards, right? I mean, if not, there's some really funky stuff going down, like the aliens that, what's that spacecraft called? Atlas, 3i Atlas is coming to take us all away or something. So I'm expecting something kind of up in this area here. So let's do it again, grind it out. Let's take negative 5 and put it up in place of all of those purple arrows and reset. Do it again. A lot of basic math, right? So if I do negative 5, now I have the negative of negative 5 minus 4 is negative 9 times negative 7, all divided by negative 5 plus 3 is negative 2. Negative 5 minus 3 is negative 8. And what we're seeing is what we want to see. When you get more substance on the bottom of the fraction, then it's going to lose power. And that's what we're expecting to shove it back upwards. So this is the negative of 63 divided by 16. And now we're under 5. In fact, we're under 4 because 64/16 would be 4. So we're at like negative 3.9 something. So now I can go left to 5, negative 5. 1, 2, 3, 4, 5, and go down 1, 2, 3, and some change. And you know what's going to happen when we do negative 6, right?
We'll get even.
It's going to go higher and higher and higher. So at this point, just because the clock is telling me that I should, I'm going to save some time and I'm going to just, I'm going to do something I'd rather you not ever do again, but I'm just going to make some assumptions and start the graph there. So we got enough to say that that's pretty good, but let's go find some stuff in the middle. The middle is vexing. So just like I did before, let's make a list of the X numbers that are in the middle of the asymptotes. What are they? What are the X's in between the two vertical asymptotes? Negative 2, negative 1. I don't need to do 0 because we already did it. And
So
1. And I don't need to do 2 because we already have an x-intercept there. So we can just do these 3. So let's work together as a team since we've only got 5 minutes. How about you 3, Gabe, Stretch, and Julie? Why don't you guys do negative 2? And then you guys in the middle do negative 1. And then us 3 over here are going to do 1. This is teamwork. We're counting on each other to not make basic math errors, okay? So again, Julie, Gabe, and Stretch, you guys are putting negative 2 in place of all of the X's. And we're doing 1 over here, homies. Got it?
So that's 10. One. Negative. Plus. Minus 8. Negative 13. I got the eights. Negative 13 tenths. Okay. Oh,
8s. Middle group, what'd you guys get for negative 1? 15/8. Left group, what'd you guys get for negative 2? 24/5. So let's assume that none of us made any mathematical errors, and if we did, we'll go back and catch it. We can. What's that?
I can verify
Sutter's wrong.
Right.
Right. Okay. Well, good. Thank goodness.
First. Yeah, I don't think
So
so.
let's graph these, and if we catch a mistake, we'll play the recording back sometime in class and we'll go back and then laugh at it and fix it. So let's all graph these points. So -2 is we're going to go up about 5, a little bit under 5. So we're going to go to left 1, 2, and up 1, 2, 3, 4, 5, and just a hair under. And then at -1, we're going to go up to almost 2. This is really taking shape nicely, very logically. And then at 1, we're going to get 3/8. I don't think we could have asked for a better outcome than this, my friends. The only question now is, how does this behave? I can almost assure you that it's not going to shoot back up asymptotically. The fact that it's gotten this close to the asymptote and is still bending downwards tells me that it's going to go like this. It's going to come this way. It's going to go through these points like this, and then it's going to cut itself across and it's going to asymptotically head downwards like this. Is that a guarantee? Absolutely not. In fact, I might just very well be wrong, and I love it when I'm wrong. All right. And on the right-hand side, same thing. Let's test some numbers. In fact, I'm not even really sure I like that. It doesn't look right. It doesn't look good, is what I'm saying. As a math guy, it doesn't look good. But let's press on because I got 3 minutes, 4 minutes. So let's head to the right of the vertical asymptote. It is 4, 5.
We don't need to do 4. Yeah,
But we've already got 4.
Yeah.
What a ding dongs. So let's do like 5 and 6.
6 or 7.
Oh, yeah, 6 or 7, 6, 7, whatever. Let's divvy up the duties again. You 3 over there, you guys are doing 5. You 4 in the middle, you guys are doing 6. Us knuckleheads over here, we're going to do 7. 48.
Let me we'll do 6, right? We're doing I do 7. I think we're supposed to do 6. 6 is 36 minus 7 is
I got
17.
-3/8. It was -15 over 40, but I divided them by 5. You guys down with that?
Squared is -36 plus 36.
Middle group, do you have something for me?
-8.
-8/27.
Yeah. Yeah. Mhm.
Take it. 5 group, do you guys have something?
Like
-3/16. Let's take a quick peek and then we'll pack up our stuff and make like a banana and split, okay? So let's head to 5 and go down to 3/16. That's going to be about a quarter of the way. And let's head to 6 and we'll go down, a little bit more, maybe a little bit more, like a third of the way. Like this. And then at -7, it's going to be at -2. Bottom line is what's happening is it's behaving the way we think it should. It's asymptotic. And I sort of alluded to this a long time ago, that with more complex rational functions like this, we can no longer rely on the assumption that the graph arms on the corners will be symmetric to each other. That only works with those basic like 3 over x minus 4, then plus 2. These more complex rationals, you can't rely on saying, oh, this arm over here is going to look like this one only backwards. That's proof positive right there. So I ate up a lot of your time, but you know what? I feel like we made some good headway. So Monday, count on it. We'll just have a nice, big, chunky, fat work day.
How many problems?
We did not do the domain on this, so I'll just, since I'm still recording, I'll just get it on here. I'll do our domain the casual way this time. I'm going to say the domain consists of all real numbers, provided that they are not equal to -3 or 3. Nice and simple, right?
Yes, sir.
Okay.
Would you perhaps on the